Thank you very much. Hello, Verona. Welcome back to the room. It's a very good time to speak, actually, because you are all now full of energy. A lot of sweets downstairs. Like Italians eat a lot of sweets. Uh, in the morning, I was for the breakfast, and then I just found lots of sweets for the breakfast. So, what's happening here? But good. Um, so, are you ready for parallel computing, though? Apparently not. Are you ready? Great. Let's start. But before that, how many of you actually have seen this picture? Gosh. Or maybe like clicking on some buttons, try to get something to work and then doesn't work and then suddenly boom, it works like magically. All of us, right? Or maybe we built those tools, isn't it? It makes us and our users so frustrated, right? It's so frustrating to have such a bad user experience on the web, right? But in fact, there are many different features right now in the browsers that we can use and kind of solve this issue. So we're gonna kind of go through them today and see what we can do. Before that, let me introduce myself. My name is MAJID Hajian. I'm coming from Norway. I'm author, international speaker, passionate software developer, just like all of you. And in my spare time, I'm also organizing a couple of conferences and meetups in Nordic countries and in particular in Oslo, Norway. Today, I'm going to talk about parallel computing and see what is it, and also talking about concurrency. And then talking about different APIs like web workers, WebAssembly, service worker, and worklets. Some of the idea maybe it's that kind of old and you all know, but some of them are quite new. I'm pretty sure for some of them you don't know, or maybe some of you know. Disclaimer is that everything that I'm talking today is just practical. Let's get rid of all theory. What is WebAssembly? WebAssembly is a stack-based, no, nothing. It's all practical. I just want you to go after the talk, open your laptop, please do after the talk, pay attention during the talk. And then start writing your code and just generate some WASM or maybe do something with web worker. Just practical things. All right. Let's get started. What is parallel computing? When I say parallel computing, I mean multiple entities working at the same time on one or different tasks, or multiple tasks. You can think of it like this picture. They are all producing one thing, or maybe different things, and different entities are working at the same time, right? But when I say concurrency, it means that one entity performs multiple tasks at the same time. All right, you can think of it like that. That's serious. This is concurrency. All right, but what is it? Why? Why do you say this? We all know that the JavaScript is single-threaded, right? It runs in the main thread, and it shares the thread with the browser, right? So, in fact, there is a browser event queue, and then whatever you have in the main thread, it just goes to this queue, and then until compilation, it runs, and then the next event, and the next event, and the next event try to be completed. Okay? So, but what if I have a long event here? Then everything is blocked until this event completes. So we all know this, right? And that's the reason you see that little pop-up or those blocking things in the UI. But well, there are some way to fix this issue. Let's get into that. The first one is web workers. Web workers are around since 2012-ish. So it's been around for a while, right? But very underutilized. How many of you actually work using web workers? You see that in this room only few, like maybe even 5. But it's around since 2012. All browser supports. Why we don't use it? Then let's go through that. Web workers. In fact, web workers spawned another instance of JS engine in a different thread. And it runs the JavaScript for you, but there is no shared state. The only way that they can communicate and with the main thread is via post messaging, right? And that's the bottleneck, actually. We're going to get to that. And it's obvious they don't have access to DOM and Windows Object. But let's see how it works. You remember this long event? What we can do here is that we can send a message to the thread once it's constructed, and then we say, hey, please do this. Once you're done, please send back the message to the browser queue. Okay, good. We could fix it. But isn't it this like concurrency? Even though we have different thread, but isn't it concurrency yet? Because these all are here, right? Yeah, where is the parallelism? Well, the thing is that if you are running a browser in a multi-core CPU on your machine, there is nothing that stops OS that actually run the different thread in a different core. But the problem, or the thing is that as a web developer, you don't know. So it's fine. So it may or may not happen. But either way, it will solve some issues. All right. There are different use cases for web workers. For instance, like you can just think of a very heavy computation or CPU-intensive computations. If you have something like this in your application today, you can post them to a web worker and hold the work on the workers, and they can do the things for you. Let's see how it works. So it's very easy. If you don't know, just to be in the same page, you have a main thread and you have a worker thread. They communicate through post message, right? Let's see it in code a little bit. We are developer. So we construct a JavaScript worker. We are a worker constructor. All right. Then you need to send the post some data to your worker. All right. Then you have a worker. You need to listen your message. Okay. You get the data, do something, and then post back the result to the main thread, right? All right, and the main thread, then you need to listen again to the message. So get the data and then do what you want. For instance, manipulate the DOM. Show some data in the DOM, right? All right, not very. That's the reason many of us don't use web worker. Right. It's very powerful, but isn't it better if I can get an access directly from main thread to this function which I define in web worker? Isn't it easier? Like I call the function and I get the result. What is these messages and those kind of things? We can get rid of that. Isn't it better? Absolutely. In fact, there is a library for that, comlink. It's been out for a while from Google developers, and it's an awesome tool, actually. it works like a magic. I'm not going to go through theory how it has been implemented, but let's see how we can use that. The same thing that we have done using comlink. Once you import everything, of course, I noticed that it's not so obvious, but there are some import things here. I'm going to share the slides after the talk via my Twitter, so don't worry about it. You don't need any picture, anything. Everything will be shared with you. No worries. So the same thing again. The only thing is that I'm going to just use or wrap the worker with this comlink. Right? And then afterwards, whenever I just call a function, I'll just get back a promise with the result. Once it's resolved, I have the data back. That's easy, right? Let's have a look at the worker. So in this case, I defined an object service. I just exposed it with comlength. And also, I defined two methods here. All right, let's do it in React. So I have one example. And it's a very common example. Many of us actually facing every day, maybe. Like you have a list, a huge list, and you want to sort based on something, right? It's quite common. So in this case, I have a list of 2,500 members, and all of them have some properties, including comments. What I want to do, I want to sort them, the user, based on the comments, right? So first, I will just create my worker and make sure that it's wrapped by comlink. Okay, good. Once I click in a button, I just call this function, sorting, for instance, ascending. And then what I do is I just pass my user to worker and say, hey, sort function, please sort it, and then send me back the sorted list. Then, once I have the result, I will just update my state, right? And then everything will get rendered. And you notice that also once I don't need it, I also terminate the worker. I don't want to just open the worker and leave it forever, right? If you don't need it, just terminate it. Let's have a look at the worker. I have a worker, service, expose it, okay, obvious. And then what you have here is just a sort function which accepts a list of user and then does this loops. That is on purpose. I don't want to optimize it. I just want to make it worse to see if it has like a big impact. And once everything is done, then the result is back to the UI, right? Very easy. See how it works. I click on the button with the web worker. You see the animation is working. It's calculating, computing, and then boom, I have the result. But once I click on the second button, you see these little things, the animation just freeze. The UI is freezing because I'm sorting all the array, right? It's a huge array. That's why it freezes everything until it's done. So how easy you can use the web worker, right? This is how one example, but I'm sure you have more example in your mind, and you can do it, you can implement it right now, after the talk, please. Let's go with WebAssembly. It's a buzzword, right? Okay, don't worry. If you write WebAssembly in your CFP, you get approval. No, that's not. Actually, I was curious about WebAssembly, and I tried different ways, and probably you have tried it, and well, okay. The first thing that it comes to your mind when I say WebAssembly, what is it? Say it loud. Rust. Good. Fast. Performant. C. C++. These are all the words that when I say WebAssembly usually comes to mind, right? But we all know that the WebAssembly is a work that you can write different things in a different language, and then you can run it in browser, right? We all know this. I'm not going to go through the theory of the WebAssembly. In fact, there are many different ways and good tools for compiling C, C++, or Rust, or even different language like Go or your favorite language. There are different tools that you can compile to WASM, WebAssembly, or WASM, right? But as a web developer, like most of us, who wants to work with C? Okay, no one. C. Is there any way actually to start working with WebAssembly today for a web developer? Yes. AssemblyScript. I experimented with AssemblyScript. I really liked it. It's a very new project, still supporting, still under development, but it's quite interesting idea. What it is that it's AssemblyScript compiles a strict subset of TypeScript, which I'm going to share with you, to WASM. That is awesome. So that means you don't need to learn any other languages. You already probably know TypeScript. If you don't know, you already know JavaScript. You can use JavaScript in TypeScript, right? So let's see how easy is that. You have you can actually download AssemblyScript from npm, and then you can actually scaffold your project with just running these commands: npx as int, the folder, and then boom. Everything is gonna be created for you automatically. Some folders, some setups, some configuration, and one main file to write all of your TypeScript code. So in fact, I wrote two functions. I wrote one function like the same one that I implemented in WebWorker, power, and I also wrote a Fibonacci recursive version of the Fibonacci algorithm, right? I, on purpose, didn't optimize it here. No optimization at all. So, you see, there are some weird type here, which are probably or probably not familiar to you. I32, it indicates, these are the WebAssembly types, it indicates that this, after compiling to WASM and using in JavaScript, is going to be number. So what you need to know, you just need to know this set of types. It's easy to learn, actually, if you don't know. All right, so before I move forward, one more thing that I need to mention is that you still need to probably work with memory allocation, because WebAssembly actually doesn't have garbage collection yet, although there are some works around that. So since they don't have it, AssemblyScript provides different modules and different tools to kind of allocate the memory and also free up the memory once you're done with your computation. Good. Once you're done, just run one simple command, ASBuild, and boom, everything is done. You're gonna get two or a couple of different files for debugging version and for optimized version for production, and then you can start using that. How you can use it? If you have worked with WebAssembly previously, you know that it's a bit of work to fetch the WASM, then do some stuff, then export the module, get the module, and then export it, and then assign. There are a little bit of work here. But what AssemblyScript does is that it provides a loader to you that you can simply just pass your WASM file to this simple function, and once it's resolved, then you have your functions ready already here. So let's see how I used it. I implemented two functions. One, Fibonacci function with WASM. Just call Fibonacci function, and then one for JavaScript version. Okay, surprise. I only remove these types, and then it's JavaScript. Okay. Same thing, right? Same function, same thing. So, and then I just also implement this function to be called. Let's move on. So, by the way, I just want to get this huge number in Fibonacci. Don't accept anything before you measure it. WebAssembly is fast, but have you tested? Have you measured? You need to measure it, right? I measured it, actually, to see if it's faster. In my case, WebAssembly for this number runs in this time, and the JavaScript one runs in this time for the first time. So the WASM was 7 times almost faster, right? Or that was the first time. The second time was almost the same. Nearly the same. And also, if you pass a smaller number, like 10, 100, the performance, like the time, execution time was same. So it's not like WebAssembly is faster. But what we can do is that the performance from WebAssembly was much more predictable. Let's have a look. You see the timer here, and without WebAssembly, the timer here. Nothing blocks, everything was fine. I'm happy, you happy, everyone is happy. It is much more predictable in WASM for performance because, let's not go through the details. The reason is that if you have a performant WASM or a WebAssembly, in the WebAssembly, if you have a performant execution, that's going to stay in that path. So it's always fast. If it's fast, it's fast. But JavaScript is less predictable. Sometimes fast, sometimes not. That's what we can say for sure. So, but find your use case, implement something, or find some module or library already, and then implement in your React or whatever application you have, and then measure it. See if it actually works faster. There are some use cases that even WebAssembly is slower. So always measure. Service worker. Of course, I need to talk about service worker because I love PWA, progressive web app. I usually speak about it. So, there is nothing related to React or any other framework and service worker. Service worker is completely independent and it can be used anywhere, everywhere, as long as a web application, right? But I want to mention it because I have a reason for that. You'll see it in a few moments. I call service worker brain of PWA. I have actually a full talk, like around 50 minutes, talking about the service worker in depth, which you can find it here, and you can find the slides later, if you are curious. But what it does, it just runs JavaScript file in a different thread. It's a type of web worker. You see that it's a different thread. And it runs in the background, and it stays there forever as long as you have this, you don't terminate this or remove this file, clean up like this service worker. And then intercept the network request. It acts as a proxy. Okay, some indication. It acts as a proxy. That means everything, all the requests, get, post, whatever, it goes to this proxy and then goes out, or vice versa. Okay, I can cache, I can retrieve from cache, I can post push notification. These are all the things that I can do with service worker, right? And that makes an application works offline. But it's very easy to register. What you can do, you can just A navigator calls service worker and then register your service worker file. And service worker file is just a JavaScript file. For your scope, you need to have one service worker only. So it's only one. You see that it's not obvious, but I'm actually registering in index.html in my main entry of the application. So only one is enough. So, but why is it interesting? So it's nothing about React or JavaScript main thread or nothing. Okay, it runs in a different thread, but why is it interesting? The reason is that I gave you the indication because you can intercept all the requests. In fact, there is, and do many things on the fly. There is actually one great example of how you can use service worker with other technology to do different things. For instance, my friend Kenneth has implemented, this is how you can listen to the fetch or the request, and he wanted to kind of decode WebP for different browsers. By the time he implemented, there was no support in some browsers for WebP. So what he did is to kind of get some libraries in C and C++, then convert it to WASM with some workaround. And then in service worker, he just fetch all the requests which ends with WebP and then decode it and send back as a different format. So everyone is happy. You're using WebP, but everyone is seeing in all the different browsers. And it all happens in a different thread and in background. That's good. That's amazing. I'm sure that now you get some idea of how to implement things in service worker, and how leverage this possibility. Worklet. This is a new API, and many browser doesn't support it yet, but let's go through it because one of them has a good support. What is it? Again, worklets are a light version of web workers. It comes to my mind immediately. Okay, so it runs in a different thread, workers thread. That's good. So what it gives you an access to low-level part of the rendering engine, like CSS. To run some JavaScript or WASM, WebAssembly, and render your graphic or process your audios. All runs in a different thread. That's good. So, and also it does it in a high performance way. There are four different types of worklets: paint, layout, animation, and audio. So, like I said, there is not a good support for all of them in different browsers. You can try them in Chrome mostly, but one of them has a better support, and we're going to actually talk about it because you may want to use it now. CSS Paint API, or you may have heard about it, Houdini's Paint Worklet, or CSS Custom Paint. These are different names that you usually hear. Let's see. First, again, it's a JavaScript file. So you need to register your painter name, or whatever you want to call it, and then you have a class with a paint, and then you write your logic. In my example here, I want to just create a background, which is a checkboard background. It's purely like painting things like a checkboard in my background, right? And all this logic is just does this. And I register my paint here with this name and this class, which is here. Fairly easy, right? Very easy, actually. What I need to do here, once I want to generate some background, or image background, let's say, I just call paint function and then say which paint I want to be rendered. Okay, but what you need to do before is you need to, once you have access to CSS and Paint Worklet, you need to just add your module, which is just this JavaScript file. And then it's available everywhere. Okay, let's see the result. Here you go. That's actually a background image, all running with CSS Paint API. But why we need to do that then? This use case is very simple, but I have a better example. If you go to the next slide, we have this QR code generator. And you see that I'm changing some value, and React is manipulating the DOM and setting some value somewhere. And then I change the mode level. You see that this is on the fly, without any performance issue. I'm generating the QR code as I'm writing. Nothing is stopped, nothing freeze, all good. And this is actually a painter generator that I'm doing that here. This is a better example. I'm sure you can think of more of these examples in your mind right now to implement with CSS Paint API. All right. What we have learned today, web workers, together with Comlink, it's an awesome possibility for all of us as a web developer to make our application work or compute some heavy, intensive computation in a different thread, and then do not block the UI, right? WebAssembly via AssemblyScript is an easy way for us as a web developer to write our TypeScript-like language, like function or syntax, let's say, and then compile it to WASM and then use it in our web application. Service Worker is a great tool to use it as a proxy and then intercept your requests and do what you want. It is mostly being used for caching or retrieving cache or sending push notification, but nothing stops you to use WebAssembly or different things in Service Worker to decode or encode or do something else. And Worklets are great tools to kind of get access to the low-level rendering pipeline, especially in particular CSS Paint API to generate images. So all in all gives your user, or it boosts user experience. And also, it makes you, as a web developer, much more happier. If you have a happy customer, happy boss, happy developer. With that said, thank you very much for listening to this talk.